This is a differential, a simple yet ingenious mechanism that allows a vehicle to turn smoothly while maintaining traction and stability. To understand why a differential is needed, let's first imagine a vehicle without one. In this setup, both rear wheels are rigidly connected by a solid axle and must always rotate at the same speed. While driving in a straight line, this arrangement works perfectly. However, during a turn, the outer wheel must travel a longer distance than the inner wheel. Since both wheels are forced to rotate at the same speed, the inner wheel begins to slip across the road surface, creating resistance, tire wear, and instability. As long as the vehicle continues in a straight line, both wheels travel the same distance and no problems occur. This problem is solved by the differential. It allows both wheels to receive power while rotating at different speeds whenever necessary. Notice how the vehicle now enters the same corner smoothly. The wheels are free to rotate at different speeds, eliminating the binding forces seen earlier. Inside the differential, several gears work together to distribute power between the two axle shafts while accommodating changes in wheel speed. Power first enters through the drive pinion. The pinion gear meshes with the ring gear, transferring rotation 90 degrees into the differential assembly. During straight-line driving, the spider gears remain stationary relative to the differential case while both side gears rotate at the same speed. As a result, power is delivered evenly to both wheels, allowing the vehicle to travel smoothly and efficiently. But what happens when the vehicle enters a corner? As the vehicle turns left, the inner wheel slows down while the outer wheel speeds up. The spider gears begin rotating on their own axes, allowing the speed difference between the two wheels. Now let's examine a limitation of a conventional open differential. If one wheel encounters a low traction surface such as ice, power naturally follows the path of least resistance. As a result, nearly all available torque is sent to the slipping wheel. The wheel spins rapidly while the wheel with traction receives very little power, making it difficult for the vehicle to move forward. To overcome this problem, many vehicles use a limited slip differential, or LSD. When engaged, the differential partially locks the axle shafts together, allowing torque to be shared between both wheels. With the limited slip differential active, both wheels continue receiving power, improving traction even when one wheel loses grip. This allows the vehicle to maintain forward motion while remaining controllable. The vehicle can now continue driving normally while benefiting from improved traction and stability. Now that we've seen how a differential works, let's take a closer look at its main components. This is the drive pinion. It receives power from the driveshaft and transfers it to the ring gear. This is the ring gear. It converts the direction of rotation and drives the differential assembly. These are the spider gears. They allow the two axle shafts to rotate at different speeds during a turn. This is the differential case. It houses the internal gears and rotates together with the ring gear. These are the side gears. They connect directly to the axle shafts and transmit power to the wheels. The differential is one of the most important components in any vehicle drivetrain. It allows smooth cornering, distributes power to the wheels, and helps maintain vehicle control. Thanks for watching, and don't forget to subscribe to Sleek Learning for more engineering animations.